Now I begin first lecture today that will be on the third topic. In these books they also mention that. This is the classical model. I will talk about the first macro model algebraically that I have seen that exists is the classical model. So this is topic 3. So I begin talking about the classical model, the first macro model. All right. Now what did I tell you in topic 1? That structurally a macro model is broken up into 3 sections: the goods market, the money market, and the labor market. The goods market and the money market constitute the demand side of the model. The labor market, along with a few other things, constitute the supply side of the model. So in the classical model, it should be the same thing. There should be a goods market, there should be a money market, and there should be a labor market. So let's talk about the goods market. If you recall, the classical model was or does talk about a long-run economic situation. And the Keynesian model or models talk about or describe short-run and medium-run economies. And the classical model describes the long run. What happens in the long run? They usually assume that in the long run there is full employment. That means any unemployment that exists is frictional unemployment. In the long run, all you have is full employment. Hence, this model that I am going to call classical macro model, this one must be describing or having those features, long run features, like full employment. In the goods market, the literature, if you go back to the original literature, the writings of the classical macroeconomists, you find that there are some scattered writings here and there, but they all put together would essentially mean, we were asked to read some of the books when we were students, from where it wasn't very clear what the classical model meant sometimes. Although we have read maybe 20, 25 pages, it still wasn't clear what that model means. But the model basically means this. Imagine a country or an economy where there is no government. So the first assumption is that there is no government. So we will ignore government expenditures. That's the first assumption. No government. All right? Given that the private economy, or what we call the economy, therefore constitutes or therefore is made up of private economic agents who have 2 kinds of activities. If you go back to your discussion on national income accounting, 2 kinds of activities, say the expenditure method, if you go back to that, is that they have the consumption activities, they spend money, and they have private investment activities. There is no government, and also we are going to assume in this classical model that it's a closed economy. There is no export and import. The country is closed to any foreign interaction with any other country. So there is no export, no import, and we would have only a closed economy. So we would, next thing we assume is that it is a closed economy. There is no export, no import with other countries. All right? Okay. Now, the problem is to set up the goods market in the classical model. To set up the goods market in the classical model, I essentially require two identities that I would make use of to describe the goods market. What will be the goods market showing? The goods market will be showing essentially an equilibrium condition. All markets show equilibrium condition in terms of supply and demand. So, what I would be looking for is what are the variables that define this equilibrium condition. We would assume equilibrium in the goods market. We would assume equilibrium in the goods market. The equilibrium in the goods market essentially would mean that supply of goods should be equal to demand for goods. Supply of goods should be equal to demand for goods. All right? This, to describe this equilibrium condition, because in economics, I tell you, we love equilibrium conditions. Everything we describe is in terms of equilibrium condition. Unless we reach equilibrium, we are very unhappy. This is how economists construct models. Disequilibrium models are very rare. All right. So, in order to set that up, what we would require two kinds of identities that I will make use of. We will use two identities. One is called the output identity, the second one is called the income identity. All right. Now, what is an output identity? The output identity would essentially say that output y is equal to consumer goods output C naught, you can call that, plus investment goods output. I naught. All right. So, there are two kinds of output that are produced. Now, the income identity essentially says real income y, that I need to explain why real income has also become y, is equal to demand for consumer goods real income is equal to demand for consumer goods plus what do they do? If they get income, they spend on consumer goods, what else do they do? Which is consumption goods expenditure essentially, plus, very good. Who said savings? Very good, plus savings. Now, this is the manipulation that I will do. This is how it is defined. Essentially, this real income of the people determine the demand for goods. This is like the expenditure approach under national income accounting in the simplified form. You spent on consumer goods plus whatever you could not spend is saved. What I would assume is that, and which I have already done, that the output is equal to real income. Let me explain this first, then I would explain the rest of the things. When will the value of goods that I produce, say take one factory, value of goods that I produce will be equal to the total income generated from that factory, and say that factory represents a company. When will that be the case? If the value of goods are measured at factor cost, then you minus the indirect taxes, all right, add the subsidies which I taught you in national income accounting, then whatever value of that good is, part has gone to wages, part as rent, part as any other raw material cost, etc., part as interest income, and whatever remained, which we call the organizer's profit, all are factor income. So, value of goods is equal to factor income generated will be true if the variables are measured at factor cost. Am I clear? But if the variables are measured at market prices, then the value of goods is not equal to factor income, because at market price you also have government's income included, which is taxes. So, the factor income plus taxes, which is government's income, makes up the market price. So, it is not all factor income. So, all I am saying here using the same notation, now you take the real value by deflating it with GDP deflator, a consumer price index, a wholesale price index. You remember, from nominal variable I can go to a real variable. 10 kgs of apple I bought, 5 rupees, 50 rupees a kg, so 500 rupees I have spent. Total value of apple 500 rupees, the real value of apple, nominal value divided by the prices, which is 10 kgs of apple. So, the real output is in real terms, which is equal to real income. That means value of output is equal to income in real terms if they are measured in factor cost. All right. So, I am not using market price variables here, number one point. Number two, if this represents the demand side and this represents the supply side, supply is equal to demand, okay, will be true under what condition? Y is equal to Y already. This is supply and this is suppose demand. Income determines demand, isn't it? Now, when will these be two equal? If the right hand sides are equal, right? Okay. Let me make a few assumptions. Let's see if this makes sense to you. Let us assume that consumer goods output is equal to consumer goods demand. All right? Let us call consumer goods output C naught and consumer goods demand, let us call that C, and let us call that S, savings. Give these variables name. Let us assume C naught is equal to C. That means output of consumer goods is equal to demand for consumer goods. Suppose we assume that. Also assume investment goods output I naught is equal to I, which is demand for investment. That is demand for investment goods. All right. Companies demand for investment goods. What are investment goods? different from consumer goods. What will they be? Machines, intermediary goods, these are demand for investment goods, which is different from consumer goods. And two types of goods are produced in the economy. Output identity is saying, one is investment goods output, machines, rods, tools, implements, and factories, etc. And then you have consumer goods output, which you and me consume, which are called final goods. Okay? This is an identity, I said, output identity. So suppose I am saying this investment goods output also matches investment goods demand, which I haven't written anywhere. Let's call that I. Clear? Now you tell me, when will the equilibrium condition hold? If this is the demand, real income measures the demand for goods, your income will measure your demand for goods, and what you don't demand is you saved. Right? Now you tell me, when would the supply of output be equal to demand for output? When will that condition hold? If consumer goods output is equal to demand for consumer goods, if investment goods output is equal to also demand for investment goods, implicit in it, implicitly assumed in the background, then when will the equilibrium condition, supply of goods will be equal to demand for goods? Under what condition? When will that be true? When savings equal to investment. This will be true when savings is equal to investment. All right? Okay. When savings will be equal to investment. So I am assuming that real income measures, this income identity gives me demand for consumer goods plus savings. Output of goods is this. Also I made one assumption that investment goods output is equal to investment demand, which is whatever, demand for investment, which is not shown here. Another thing what you can write is, as I have written output, which is supply, and you can write demand for goods is equal to consumer demand or demand for consumer goods demand plus investment goods demand. Plus investment goods demand. Now, in equilibrium, supply is equal to demand. Therefore, what you have is consumer goods output plus investment goods output is equal to consumer goods demand plus investment goods demand. You can write that. Therefore, if consumer goods output is equal to demand for consumer goods, if I assume that, then automatically investment goods output will be equal to demand for investment goods. All right? Now, given the income identity, what you have is, you can write y is also equal to c plus s. Therefore, through comparison, this is also y, this is also y. Remember, this is also y, c naught plus y naught, this is also y. So, given the comparison real output is equal to real income, it follows that c and s and I, which I have written earlier, therefore, it follows the income identity. Given the income identity, it follows that s should be equal to I. You can put it this way, instead of jumping one stage from the output identity and the demand identity I didn't show, it can also be shown, just one assumption is required, consumer goods output should be equal to demand for consumer goods. Therefore, investment goods output should be equal to investment demand. Now, since y and y are the same, C plus S should also be equal to C plus I, C are the same variable, therefore, S should be equal to I in equilibrium. You can put it this way. I jumped one stage, I did not show the demand kind of equation or identity there. The total demand identity, I did not show. The total demand identity means it will always be true. Total demand consists of two items, demand for consumer goods and demand for investment goods. Total output, again an identity, it will be consumer goods output plus investment goods output, whatever that amount is. If you make one assumption which I made, assume C naught is equal to C, then also assume is not required, this follows. All right? If you assume C, then this is not what is required. C naught is equal to C, then I naught, from the equilibrium condition it follows that I naught is equal to I. Investment goods output is equal to investment goods demand. The basic point is, these identities establish that in equilibrium savings should be equal to investment. That's the main message that comes out. That means whatever money in real terms the economy saves, maybe they put it in the bank, is also demanded by the firms for investment purposes. They balance in the equilibrium. All right. If you are more or less okay, therefore, what I would do is the following. Therefore, the goods market equilibrium condition so the goods market equilibrium condition says or implies savings is equal to investment. This is very important. In the classical model, savings is a function of R, where SR is positive. SR is nothing but ds dr, that derivative, and IR is a function of R, where IR is negative. R is real interest rate. R is real interest rate. What it says is that as the interest rate in the economy increases, savings increase. If banks pay a higher interest rate, then the economy saves more. And if banks charge a higher interest rate when they give out loans to the companies, companies demand less amount loan, because interest rate is the cost of borrowing for the companies. If they are taking a loan from a bank and bank says this quarter interest rate will be higher, they are discouraged to borrow, because that increases the cost of borrowing. So, the interest rate has two different kinds of relationships, or savings and investment has two different kinds of relationships with interest rate. Savings have a positive relationship with interest rate. If interest rate is higher, people like to save more, put money in the bank, because the interest rate gives them a better return. So, they prefer not to spend now, because savings is not spending, not to spend now, spend in future when I earn more. Whereas, for companies, if the interest rate is high, then they are discouraged to borrow. So, the borrowing amount, loan amount goes down, therefore, their investment demand also goes down, they demand less. This is a standard relationship or standard functional relationship of savings and investment that is easy for us to understand using our common sense, our experience, whatever. However, there is a catch. Why is the real interest rate? Remember one thing which I probably did not mention, in macro models, unless specified, all variables are always defined in terms of real magnitude. So, consumption, investment, income, they are all in real terms. Because in money terms, I told you, it can be very confusing if the output volume is going up or not. Because prices can increase, and in money terms, nominal terms, the value of output can be shown to be higher, which does not necessarily mean the physical volume of output is higher. Therefore, in macro models, which I told you, or I was talking about that in relation to topic 2, real variables, constant variables, etc., those variables definitions I used. In macro models, all variables, unless specified, that this will be in nominal terms. For instance, one variable in nominal terms which you will find in macro models is prices. Prices are not in real terms. Prices are always in rupee terms, current prices, nominal terms. Then another variable which you will find in nominal terms later you will see is money supply. Money supply is not, money supply is, we may use a real value of money supply, but money supply is explicitly mentioned in macro models, which is in nominal terms. How much rupee supply is supplying, floating in the economy. I will define money supply later. All right? Okay. Now, here savings is a real savings in the economy, not nominal. That means the money they have saved in physical volume, they can demand or can be used to buy more goods. Higher savings means. Investment also in real terms, and they are function of real interest rate. Now, you would ask me the question, sir, the interest rate that banks pay you when you open an account, a fixed deposit account or a savings account, or when a company borrows money, the interest they ask them to pay, is it really the real interest rate or the nominal interest rate? What kind of interest rate are they? Well, that interest rate which the bank tells you, which is the deposit rate, the savings account deposit rate or a fixed deposit account rate, 8%, 7%, 9%, whatever it is, they are not real interest rates. They are nominal interest rates. Then you would say, sir, why do you have the real interest rate? If they are nominal interest rates, why do you have the real interest rate? Well, one simple quick answer to that is that these static models, classical model or the Keynesian model, when we talk about that, we don't have dynamic variables which are time derivative variables. So, we don't talk about inflation directly here. So, normally what we do, any price change, anything we show that as a one-time change in price, a two-time change in price, not a persistent change in price, which is the basis for inflation or deflation. So, since they are static models and we don't have dynamic models, that y dot dy dt, p dot dp dt, or whatever, s dot ds dt, we don't have them. We essentially have the static variables. We cannot really talk about inflation. So, we in some ways we can give you a hint as to what inflation would mean in a model like that, or what this model would have for inflation. But we directly do not have, explicitly do not have inflation as a variable here. Inflation variable, usually we use pi as the notation. You will not see pi, but you will see p. P is price level, which can be CPI, GDP deflator, whole WPI, whatever. And if changes, it's not a persistent change that we can talk about. We change once in a, something has changed, it has also changed. Now, nothing is saying it will keep on changing beyond that. So, we don't have inflation, number one. Since we don't have inflation, we need not talk about nominal interest rate. You would say, sir, nominal interest rate and inflation, what is the connection? Well, there is this famous economist, early 20th century American economist, wrote some books and they are still used. And he defined one of the most easiest way and probably the correct way, the relationship between nominal and real interest rate. Let me write it down before I go into further discussion on the classical model. What he wrote, Irving Fisher, and Irving Fisher gave a relationship between nominal interest rate and real interest rate. He said that nominal interest rate is equal to real interest rate plus inflation rate. So, nominal interest rate is real interest rate plus inflation rate. So, suppose I say in terms of algebraic notation, nominal interest rate is NR, which is equal to R plus pi. So, that is the relationship he established, an algebraic relationship. It is like an identity. Nominal rate is always equal to real rate plus inflation rate. What does it mean? Well, the intuition here is probably not very difficult. How can I explain that to you? Let me explain that to you. Suppose a businessman is borrowing money from a bank and paying in the nominal rate of 14%, 16%, 18%, whatever it is. That is the bank interest rate, loan rate. We call that loan rate in India, elsewhere also, the loan rate. Two standard rates are there, interest rates in banks. Deposit rate, your savings account वगैरह, multiple deposit rate भी होता है क्योंकि there are various kinds of savings account, etc., fixed deposit, and one is the loan rate, and also there can be multiple loan rates because there are various kinds of loans, working capital loans, fixed loans, etc. Money and banking courses like that will talk about that. We need not go into that. We know that when banks give out loan to a company, company is supposed to pay an interest. That's a loan rate. And when we also know when we open an account, put money in the bank, we get a deposit rate, an interest rate, which is called deposit rate. All right. Suppose the bank has borrowed money at 18% something. Now, when the bank borrowed the money, he has also stockpiled with that money some raw materials, etc., for whatever purpose, all right, for his investment purposes, for his company purposes. He has bought raw materials at the current prices. And also some stock exists from the previous period. And then after one period, whatever that period is, say 1 year, usually interest payments are like spread over 1 year, they counted per year and then maybe broken up into quarters, that is different, but 1 year per annum they call. These interest rates are usually per annum. So, 1 year the company has also produced some goods and brings to the market. If there is an ongoing inflation, the company, when he brings the product to the market and sells it, what happens? The costs are at the previous period rates, but there is an inflation, so he sells the good with an inflation rate added to the market price and he makes extra profit. He could have sold in yesterday's price because the costs are in yesterday's price, but with inflation, prices when he brings the product to the market, prices have gone up 5%, 10%, whatever. He sells the good at a higher price and makes an extra profit, which you can call a premium, extra wala, okay. Then when he goes to the bank and pays the interest rate after one period for the loan he has taken, the company has taken, the company is essentially making a payment of real interest rate, because the pi, which is the inflation rate, part of the nominal interest rate has two parts. The pi part already he has recovered by selling the good in the market at a higher price this period. So, effectively he pays an interest rate to the bank which is R and not NR, because the pi part is already deducted from it. So, NR minus pi. Pi is the general inflation rate which has already given him an extra profit. So, that part on the loan he has already kind of recovered, and intuitively roughly speaking what I am saying. So, effectively what he pays to the interest to the bank is a real interest rate. So, when a company or a firm or a businessman borrows money from the bank, what he looks at is, when the bank says this is the interest rate, he really looks at the real interest rate. He takes into account the current inflation, because inflation always gives the privilege to the company to sell the good at a higher price next period, and that comes as an easy interest payment through the market to him, which he need to just transfer to the bank, and what he effectively pays from his pocket is the real interest rate. All right? So, to the company, businessman, what really matters is the real interest rate. Now, for a depositor, consumer, a saver who puts money in the bank, why savings is also a function of real interest rate. When you put money in the bank and get the interest rate after one period, prices have gone up. So, the interest rate 9%, you cannot really use in the market to buy goods for yourself. 9 minus 5% inflation rate, because prices have gone up, has become more costly. Therefore, 9 minus 5, 4% is your net gain as an interest income from the bank. Do you understand what I am saying? So, for a saver, it's a loss if there is an inflation, because the purchasing power of money has fallen. Same money, 100 rupees, cannot buy that amount of goods, because prices of goods have gone up. So, with the interest income coming to you after one period, doesn't give you, don't think 9% extra income ho gaya mera. Actual income mera jo hua hai, which consumers don't think usually. Consumers only look at usually nominal interest rate. Unko buddhu banate hai, inflation. But effectively what happens is that his real income that he has got received from the bank in terms of interest income is the real interest income, not the nominal interest income, because the inflation will cut into its income in terms of higher prices, and he won't be able to enjoy that money because of higher prices he pays to the shopkeepers. So, savings and investments are both function of real interest rate. It is important that we do in macroeconomics. We don't make them function of nominal interest rate unless we have a very specific reason to do that. All right? Similar thing you will find in textbooks. Explanation of real interest rate is in terms of the various things, in terms of productivity of capital, etc. I can talk about that. I will talk about that a little bit later. They equate real interest rate with marginal productivity of capital, which requires some microeconomics. And marginal productivity of capital is essentially the same thing. As more and more machines are hired, you get an extra output by an extra machine when you hire or you buy. So, we need to compare that value of extra output with the interest rate, because interest rate is my cost by obtaining money from the bank, and the extra output that you get, the value from selling the extra good that you produce from getting the loan and buying the machine. So, in equilibrium, there is an equilibrium concept there. Real interest rate should match marginal productivity of capital. Marginal productivity of capital, for those of you who has not taken microeconomics, may be a difficult, you can use Mankiw's book to find out what it is. It's essentially a demand function for capital. So, the marginal productivity of capital declines, that they say. This is called diminishing marginal productivity. And in equilibrium, real interest rate matches with marginal productivity. Why? Because real interest rate is, to a company, is like a cost that he pays to the bank for borrowing money, but the company's benefit is, by borrowing the money, it purchases some machines, something else, produces an extra good which he sells in the market and earns a revenue. So, the extra revenue that I earn, I compare that with the extra cost that I incurred by borrowing money from the bank. So, there is an equilibrium concept there involved. As soon as the cost is more than the return, I stop borrowing money. So, this is marginal productivity of capital in terms of the return, and the cost of borrowing is in terms of R. So, there is another explanation that is there in the textbooks, is the R has to be compared with marginal productivity of capital. But I do not want to go into that, because many of you do not have much microeconomics, but if you open Mankiw, etc., Mankiw has another book also, macroeconomics, but some principles of macroeconomics, something it is said, where these explanations are there. Why investment is a function of rate of interest, an inverse function. It is an inverse function, because if rate of interest goes up, which is the real rate, companies invest less? Because it's the cost of borrowing. And why is it so? Why is the cost of borrowing so important? Because essentially you compare that with the return that you get from borrowing money. If the cost is higher, given diminishing margin and productivity, you employ lesser amount of capital. So, I am scared to go into that microeconomics, because many of you have admitted being a summer course into this course without having the microeconomics knowledge. But if you want to check that out, you can check. It's a demand function. It's a very simple thing in principle macroeconomics. So, what I'm going through right now is the goods market, remember, and please check if my initial lectures today, I hope they are not confusing. The income identity, goods identity, the demand also has an identity. Demand for goods should be consumers' demand and investment. And therefore, from that it follows in equilibrium, if supply is equal to demand, then saving should be equal to investment. Please find out if that, because in the initial first 15-20 minutes, I skipped one step there, which I put it here on this side of the board. So, find out if they are all right or not, and let me know. We can have a discussion class later. So, goods market description I haven't completed, but I have just told you algebraically. Essentially, it boils down to goods market equilibrium means savings is equal to investment. So, I need a diagram here, I will draw that, which describes the goods market equilibrium condition. In books, you will often find there is a diagram. I don't think the diagram is required, but there is a diagram. The diagram is as follows. They have savings and investment here and real interest rate, and investment is a downward sloping line, savings is an upward sloping line. So, you have an interest rate equilibrium value, and here where savings is equal to investment. This kind of a diagram can be drawn. It's not very much needed, but this diagram you will find in books. So, this is the goods market equilibrium condition. Next, let us go to the money market. The demand side has two markets, goods market and money market. Let us go to the money market. Again, in the money market, you have an equilibrium condition that would dictate things. The equilibrium condition is very simple. Supply of money should be equal to demand for money. And since in macroeconomics most variables are expressed in real terms, and you can imagine demand for money would be in real terms, the supply of money is mentioned in a very funny way. Supply of money is written as the supply of money in nominal money, the rupee that you have in your pocket, assume, but that is divided by the price level so that it becomes real supply of money or supply of real money. Divided by price level it is written, simply because the equilibrium condition will be equal to demand for money, and the demand for money would be kind of in real terms. So, nominal cannot equal to real. So, make the nominal variable a real variable by dividing it by prices, and then you have the demand for money. Now, supply of money, what it is? Of course, we all know the cash that we carry. Unfortunately, I don't have much money, but it doesn't matter. It's good probably. Otherwise, I don't know. I might get robbed. If I have a supply of money, everybody knows this currency, cash. And currency consists of two items. This is what I teach in the other course, money and banking course. It has notes and coins. So, supply of money is notes and coins. But if you look into the definition of money supply, you have to go to the boss of money supply in a country. The boss, the big boss of money supply is the central bank. So, in India it's RBI. So, RBI decides what the supply of money is going to be. Then we will see there that the supply of money has all kinds of definitions. If you talk about M1, there is one supply of money called M1. then you have this currency with the public plus demand deposits in banks or with banks. Demand deposits are essentially savings account deposits, etc. These are called demand deposits. The other kind of deposits with banks are time deposits. Time deposits are like fixed deposits, recurring deposits, etc. So they take the demand deposit, not the fixed deposit value in M1. Together it is called supply of money. So supply of money has various definitions. It can have a M1 definition in India. Now if you go into M1 definition in the US, you will find it's different. There is an, in the US, you will probably find M1A, another definition, which doesn't exist in India. Then we have in India M2. In US, you also have M2, but it's very different M2. Then there is the famous M3 in India we have. So there are various ways you can define money. In simplest form, for our model, macro model, M can be considered to be M1. That is the money you have in your savings account, which is nearly cash. You can go to the bank. When the bank opens, you write a check, withdraw the money, and go and spend it. And also currency with the public that exists in our wallet, at home, with my parents. They are all part of M1. So to me, M1 is a suitable definition of M. But there are other definitions of M that I am trying to tell you, which we need not know now. M1 से बिना है M2, M3, M4 बाप रे बाप जरूरी नहीं है. M1 काफी है हम लोग के लिए for macro models. That is essentially the cash or near cash, which is with the bank, and they accept that in today you have automatic teller machines. So the cash is even easy. You don't have to wait for the bank to open. You can go to the automatic teller, insert your card, take the money out, provided you get good money. Sometimes I've been told you don't get good money from there. That's it. Anyway, so you can go to the bank. So M over P is a standard definition of supply of money. The question is, what is demand for money? Here comes the macro issues. This was a big issue in the 60s and 70s, even the 80s I found. The demand for money. In the classical macroeconomics, the demand for money was a very simple demand for money. I think it originated, I'm not so sure, it had two origins. One, a demand for money kind of a thing was developing with Irving Fisher in US, whose name I wrote when I was trying to describe the relationship between nominal interest rate, real interest rate, and inflation. Very important. He was trying to do something. At the same time, in England, Cambridge, the demand for money theory was developing on the other side of the Atlantic. It's very interesting. Economics, if you look into the history, it has been simultaneously sometimes developing on both sides of the Atlantic. Not really one is cooperating with the other one. Sometimes they belong to different schools, even fighting, but similar kind of thinking on some issues. So the demand for money in the classical macroeconomics is only of one type. In Keynesian macroeconomics, we will find various other kinds of demand for money. The usual demand for money that we have in the classical macroeconomics is the transaction demand for money. Transaction demand for money. Transaction demand for money hypothesis, which primarily developed in the Cambridge University, essentially says that people demand money for transaction. They have to pay the rent, they have to buy the sabji, they will have to pay the children's school fees, they will have to go to the city to buy other goods, all are transaction purposes. So that's why people demand money or demand cash. Hence, if that is true, if you accept this hypothesis, transaction demand for money, then it's very simple that the transaction demand for money, if you call that real money, MD, will be proportional to the real demand for money, P, you can say is proportional to real income. Your demand for money for transaction purposes would depend upon your income. It's very simple. It's proportional to that, in fact. If your income goes up, you spend more. All right? Where H is the proportionality factor lies between 0 and 1. All right? So, demand for money is proportional to what it is saying. Demand for money is proportional to income. And the proportionality factor H is less than 1. This is the proportionality factor. H is the proportionality factor. Okay? All right. So, this is a simple demand for money. Now, what they do in this macro model for supply is equal to demand in the money market essentially would mean that M over P would be equated to HY will become is equal to HY, supply is equal to supply of money is equal to demand for money. So, M over P is equal to HY, and then they do a very interesting thing. There comes the manipulation. This equation is usually not written in classical model. What they write is that or M into 1 over H is equal to Py, and then they write MV is equal to Py, where V is called velocity of money. V is called velocity of money, and P into Y, what will it be? P into Y? Y is real income, P into Y? What did you say? Very good. Py is nominal income. Py is nominal income, and you will not know this MV also has a name. MV together, velocity of money and M together, this whole thing together has another name called total effective supply of money. Is total effective supply of money, MV. Now, what is velocity of money? Here is some more intuition which I have to explain to you before I proceed further, and I hope you would understand. What you are saying here is the total supply, real supply of money, or total nominal supply of money, if you cross multiply P, will be H into Py. Py is the nominal income. So, you are saying and H is a factor less than 1. Okay? Now, if M is equal to HPY, if P goes there, you are saying that H is less than 1. That means the total supply of money, the currency you need at any point of time in the country in rupee terms is less than the total value of goods produced in the country. The currency needed in the country, or the way that exists in the country, M, is less than P into Y, the total value of goods produced in the country, which will be bought and sold, transacted. Because H is a factor lying between 0 and 1. So, it is like 80%, 90%, 70%, 60%, whatever, 0.6, 0.7, 0.73, 0.8, 0.81, whatever. And if m is equal to h, which is a proportionality factor less than 1, into p into y, the total value of goods that you have produced in a country in a year, which will be bought and sold, you are saying a very important thing here. You are saying the total money required to buy the goods is less than the total value of goods that it will buy. Here comes the question of velocity of money, which I told you. This h, when it transfers to the other side, then it becomes 1 over h, and 1 over h becomes v, I told you. If h is less than 1, 1 over h is more than 1. So v is more than 1. And what is this velocity of money? You have to understand this. Velocity of money in simple terms is very simple. I have this 100 rupees after class. This lecture, I usually get very thirsty. I go to the Southern canteen, Southern Lab canteen, go and sit there. Sometimes these days I cannot sit outside, it's so hot. I go in and sit, order a thumbs up or a Fanta or whatever. Destroy my liver, but every day I do that. Fortunately, only 3 days a week I destroy my liver there. अच्छा, तो जाके उसको पीते हैं. अब बाहर का देश में जब करेंगे, they will find more things are available to destroy your liver. You can try that out there. That's. Now you destroy your liver, I go there and buy it. That 100 rupees I give him, he gives back the change to me. That 100 rupees, does it stop there and cannot be used anymore to buy goods? No, in the evening when he is going back home with his wife, there is a canteen man with his wife who sits there. They realize that they have 2 kids at home, they should buy something for them. They stop at Rawatpur or Kalyanpur, get off the auto, buy some goods, go back home. Maybe sabji, maybe gifts, which I do for my kids, for instance. So I go home and buy the goods, all right. So he takes out my 100 rupee note. If I have a man watching it, you know, a spy or something, or a camera, like these fellows have cameras, he will watch a camera, he says, oh my goodness, he takes out my 100 rupees. And then gives it to somebody in Rawatpur, who following day, I see even he gives it to somebody else. So what happens? Currency doesn't stop with one-time use. Currency has a velocity of circulation. So the total effective supply of money has to match with total value of goods. But money itself is usually much less in amount than the total value of goods, because the money circulates in the economy. Okay? Like the air circulates. Air, impure air, destroys us here, then travels to the next village, destroys somebody there, and you are probably wishing it goes to the faculty building, destroys some more people there. Thank God IIT Kanpur has shut down. You may wish that. So it keeps on traveling. Similarly, money, cash keeps on circulating. It's a velocity of circulation it has. And essentially it starts the moment I write demand for money is proportional to income. That means I require less than my income to buy goods. It's not very clear, but I set up the problem. Then when I put the equilibrium condition with the money supply, here supply is equal to demand, and I bring it over here, then I realize if I transfer h to the other side, it becomes v, which is more than a number. Then I see the total value of goods is equal to now not m, but mv, where v is a number greater than 1. All right? 3, 4, 5, whatever the velocity of money, average velocity of money is. In fact, in my money and banking course, I show the average velocity of money in India, what number is. It's about 4 or 5 now, 4 point something. All right? Average velocity of money. All right. So like for a miser, for instance, when he receives money, he's very seldom bringing it out to spend. So velocity is very low. But what you call that spendthrift person is usually very high. He keeps on spending money. So then I take up issues in money and banking, that other course, as to whether the velocity is going up or down in India. Why is it so? Anyway, I need not get into that. So mv is equal to py you have. Now the funny thing is that I started talking about transaction demand for money from the Cambridge version, that the Cambridge economists were thinking like that. But the mv is equal to py, this relationship that I have written, was developed without realizing that that is nearly equal to that with the equilibrium condition in the Cambridge version, without realizing that. This particular version, this particular yellow color version, developed with Irving Fisher writing it. Very interesting in the US. Whereas the Cambridge economists were going along that line and was writing something like M over P is equal to HY. So today in classical macroeconomics, the money market has both the descriptions and things that are to be discussed under these two things. One coming from the Cambridge tradition, one coming from the classical macroeconomics like Irving Fisher from the US. But both mean the same thing to me at least. All right? Great thinkers may debate about it. We need not debate in class because at this point, at this stage, you need to just know a few things. You need not go into the minute details of it where they can be argued against or for. So MP is equal to PHY is the money market equilibrium condition. And you can also draw a diagram here if you wish. M over P is equal to HY, you can draw a diagram, whichever way you want. One way of drawing it will be, they are all in disconnected diagrams, so I'm not drawing them, I'm not putting so much emphasis at this stage. But the diagram can be drawn. For instance, the money market diagram will be, I can have M over P here, and I can have, you would wonder, sir, what will you put there? Well, later I need something like this, so let me draw it here. Say rate of interest will be an important thing for supply of money, demand for money, later you will see. There we have the rate of interest, I am putting a rate of interest. But rate of interest is not a variable. Rate of interest is not a variable, unfortunately. So it will be M over P is a direct line, which is M over P, some value, and then that should be equal to HY. So suppose I put Y here, so demand for money will be HY. H, M over P over demand for money is HY. H is some fraction. So essentially for equilibrium condition, it will coincide, HY line. All right? So it will coincide with this, and that is equal to HY. That what will it be? No big deal. Hardly any interesting diagram. But I need this later. I need this later, I will come back to that. All right? So no interesting diagram I have here. Anyway, I tried to claim that there are interesting diagrams that you can draw. Supply of money is equal to demand for money. It's simple, a vertical line. All right. So you have the money market and the goods market. Yes? No, that is the HY line. No. HY is equal to M over P, this equation I am drawing. That's all. It's no interesting line. But I need this later. I will tell you why I need this later. No big deal here. You really cannot draw a nice savings and investment line I drew for the goods market. For the money market, you really cannot draw a nice diagram. All right. Now, if this part is all right, then we have the goods market and the money market covered. So now I can go to the final labor market. All right. Now, essentially why I go to labor market is I want to describe the supply side of the story. This is the demand side of the story. So now I have to describe the supply side of the story. Here again, unfortunately, some microeconomics is required to understand some of the things. So we would talk about now the supply side of the story. The supply side of the story, the demand side of the story is over, money market and the goods market. The supply side of the story is you have essentially the production function. You have to write the production function because how would a company supply without a production function? So here is some microeconomics that are coming in, but let's see how you feel comfortable with it. First, I have to describe the production function. And the production function usually is written like this. Y, the output, is produced using labor, let's call that N, and some fixed amount of capital. This is labor, and this is some fixed amount of capital, and some technology, etc., are given for the country. You can think about this. Best way is to think about at the micro level, a company producing something, a small y. A company is producing a small y using, say, in a simple world, some machines and some people are hired, labor. The machines are fixed. This is usually, we assume that. Now, this creates a controversy sometimes in macroeconomics. Sir, you're talking about classical macro model, and you're also talking about what you say a long-run situation. But what we learned from microeconomics, in the long run, capital or any other factor, no other factor can be fixed. This is microeconomics, what it says. What is the long run in microeconomics? In microeconomics, long run is no factor can be fixed. Anything can be variable. In the short run is a case where some factors are fixed. For instance, you take the classroom, where we generate education, we produce education, good, all right? Some good, some knowledge. Now, if you take the number of chairs, this is fixed in the short run. In the long run, IIT can expand the wall, add more chairs, then it becomes a variable factor. It has changed. All right, now, one thing is very variable here, which you know, is the, for instance, say the number of students, if it is an input. The number of students which is an input, of course, is a variable. You can see, look around, so many chairs are empty. You can bring in more people. Tomorrow, I see there are fewer students. Even what is present today is not present tomorrow. So, labor is always a variable factor, which is very convenient. In fact, that's what happens in the Western world, in the capitalist society. There's a recession, a company lays off workers. You won't hear a company selling assets. The first thing company does, lays off worker. Very variable. Now, you're out of the recession, you're in the recovery, economy is improving, you keep on hiring people. The job, the headline news comes, such and such company has hired or called back 10,000 of its workers. In the recession, 2 years back, such and such company laid off 5,000 workers in Europe, 6,000 workers in Asia, something else happened. This is what the multinationals do continuously, or any company. So, labor is often a variable factor which changes even in the short run, and of course, it can change in the long run. But in the long run, according to economics, but to microeconomics, is a situation where some factors are fixed, and usually capital is looked upon as one of the factors which is fixed. Another one can be land, fixed. This ये land के ऊपर मेरा factory है, वो बढ़ नहीं सकते, वो बढ़ेगा only in the long run if I buy more. All right? Okay. Now, in this supply function, you see K naught. K naught basically means it's a fixed factor. All right? Capital is given, along with some technology, etc., other things. So, you wonder, sir, long run you're talking about, how come capital is fixed? I guess what they have in mind is a very abstract thing. This is for convenience because this is how production function has developed. Is that what they have in mind here is that in the long run you reach some sort of an equilibrium where then the capital gets fixed. It's not over the entire long run period, capital has been fixed, but when you reach the equilibrium, capital gets fixed. You have reached the best possible state. In that sense, capital is fixed in the long run, all right? And labor is still variable around long run, very interesting. So, how they manage this analysis sometimes gets very confusing. They call classical macroeconomics long run, they have labor variable, capital fixed, etc. Now, this production function typically exhibits the following properties. Given the fixed factor, if I keep on hiring people, I get increased output. But the additional output keeps on falling. So, when I had nobody working, I hired one person, I get an output. I get 2 person, I get a huge amount of output. Then 3 person, some more output, not that huge amount. 4th person, some more output, not that amount extra that I got. So, the incremental output keeps on falling. We have increments, we have increases in output if we hire more people, and then we can reach a saturation point. In relation to the number of chairs, I cannot have any more student here. They would be standing there, disturbing the class, sitting on the passage there, on the stairs. I can reach a saturation point in relation to the fixed factors. That can also happen. But initially imagine in this classroom, as happened this morning when I came, one person here, two persons there, one there were sitting. Then gradually more labor came and more product. I hope it is getting more productive. But the incremental output doesn't increase. With microphone advanced technology it does, because my voice reaches at the back row. Earlier my voice never used to reach the back row. So the production function that you have here, you can consult a microeconomics book. It simply can be drawn like this. You have n here, you have y here, and it is a line like this, which is y is equal to f n k naught. What does it mean? Y is equal to n k naught. What does it mean? That incremental output, which is the marginal dy dn, all right, is greater than 0, tangent is upward sloping, but reaching a 0 point at that saturation point, 0. The tangent measures dy dn, the incremental output. The tangent measures the dy dn, but you can see the tangent is getting flatter. Means dy dn, the incremental output, marginal output is falling. So if you have a second derivative of that, this slope basically means d of dy dn with respect to dn is less than 0. The slope of the function is falling. Dy dn is the slope, and second derivative of that is less than 0, means the slope is falling. The line is getting flatter. That means every time I hire more people, I get an extra output, but that extra is shrinking. पिछले यूनिट में इतना, इस बार और अगले बार और कम, so और कम, I'm reaching a saturation point basically. So I cannot keep on hiring anymore. Enough we have. And that is always in relation to the fixed capital or the fixed factors that I have. If I change the fixed factors, then the whole ball game changes. The dimension changes. Then I have more people. I can have 1,000 students here with microphones everywhere, you know, like a big hall, like a concert hall or something. Theater hall, 700, 400, 500, 600 आदमी बैठे हैं, थिएटर देख रहे हैं, कोई तो प्रॉब्लम नहीं हो रहा है, एक ही स्टेज में तो परफॉर्मेंस हो रहा है. ठीक है? All right, do you understand what I'm saying? So this production function is what we teach in microeconomics, has a diminishing marginal productivity. It is called diminishing marginal productivity. The marginal increment in output diminishes. It exhibits diminishing marginal productivity essentially because the fixed factors of production are constant. So in relation to that, if you keep on hiring people, you will get extra output, but not necessarily. For instance, you have some computers. You had one person first, then you have all persons hired, whatever optimum you require. If you hire more, what will happen? He doesn't have a job. Then he fools around, goes and sits with you for 5 minutes, goes and sits with him for 10 minutes. He doesn't have work. It disturbs him. It disturbs that. Output can start falling even. That can also happen. The tangent can become negative, downward sloping. So dy dn need not be positive. Dy dn can become negative even. But we don't think that any rational economics or rational firm or in economics that dy dn would keep on falling and to the point where it becomes negative or 0. We usually don't think that that will happen. Why would a company keep on hiring people? Only where it happens, you know, it happens in public sector companies. It used to have banks. कोई minister आए power में, minister बने हैं कोई party से, and then he orders the bank manager, hire 50 of my people. They don't have any work. So banks become oversaturated with people, and you have what you call negative marginal productivity of workers, because they were hired under pressure. But a profit maximizing firm would never do that. A profit maximizing firm would hire so long its profits are maximum or increasing. And it will stop hiring if the profits start falling even. Forget about output falling. If its profits start falling, it stop hiring, which I don't have an equation here, profit. I'm talking about only the output level. But in public sector companies, it can happen. It used to happen in India. You keep on hiring people, so you don't need them. and to show the country or whoever that you have hired people or to do favor to the voters who have voted you to power. So, we are not talking about public sector companies here. So, F and K naught labor capital output keeps on increasing this production function. So, what we have essentially, we write a production function under the supply side relationships where labor market is important, and we put the productivities Fn greater than 0 and Fnn less than 0. We put down these conditions Fn greater than 0, Fnn less than 0, which you have understood, first derivative and the second derivative, which describes the production function. All right. Now, after this, we need the labor market, and the labor market, as you know, the labor market will have, under the supply side, the labor market will have two equations, labor demand and labor supply. Labor demand and labor supply. The labor market will have two diagrams, the labor demand and the labor supply. Now, again, unfortunately, I have to bypass that. You can consult a book, this microeconomics. You can do it later, read up. Both the labor demand curve and the labor supply curve has a micro theory behind it, although these are macro relationships. This is macroeconomics that you are studying. But these functional relationships have their origin, their root in microeconomic theory. Like the production function, which is a macro production function called aggregate production function for the economy, essentially comes from micro theory. In theory of firm, in microeconomics, we use a company's production function like that. Similarly, the labor demand function and the labor supply function also come from a micro theory with a micro underpinning. So, the labor demand function essentially comes from the theory of firm. And the theory of firm in microeconomics says that a company maximizes, a firm maximizes profit. Pi, which is, pi was inflation, na, oh, isko lagao aur kuch. Profit. माइक्रोइकोनॉमिक्स में पाई हो जाता है प्रॉफिट, मैक्रोइकोनॉमिक्स में पाई हो जाता है इन्फ्लेशन, बहुत झंझाट है इकोनॉमिक्स में. अच्छा, firm maximize a profit. So call profit may be called that something like a variable PR, which is what? Which is the total revenue that the company earns, total revenue minus total cost, right? That's the profit, total revenue minus total cost. That's very simple. So, what is total revenue? A company's total revenue is, suppose price which is given P naught, say small price P naught into some output it produces Y, all right, minus total cost, say wage into N, N is labor, capital N was labor here, for a company small n is the labor, minus some rate of interest into small k naught, which is the capital stock it uses. So, that is the total cost, the labor cost and the capital cost. I subtracted minus minus. That is the profit. And small y also has a production function like relationship, which is a function of n and k naught, where small y is equal to some function of n and k naught, the production function of the company. So, the profit of the company is total revenue minus total cost. Total revenue is the price at which I sell the good and come back home with the revenue, that is the total revenue, sales जिसको कहते हैं sales revenue, minus the total cost k naught. All right. Now, if you maximize this profit, if you use the optimization calculus, you get the first derivative set to 0, all right? So for maximum, set the first derivative 0. For maximum, you have dPr with respect to d small n is equal to 0. That is, you keep on hiring people till your profits are maximum. Capital is given, so I'm trying to maximize profit here, means I keep on asking students to come, who are paying a fee to come, till my profits are maximum. So I have some costs in mind, and students' fee gives me the total revenue, and I hire till my costs and revenue balance in certain way, so that my profits are maximum. That's kind of an example I'm trying to give. So dPr dn 0, you put dPr dn 0, what you get here is that this implies P naught is a constant d small y dn minus omega is equal to 0. देखो ये equation में, if you differentiate with respect to n, you get P naught, the price, into dy dn minus omega. Suppose omega is also a constant. Suppose omega is also a constant, the wage you pay. Suppose this is also a constant. They are all constants. So omega naught ho gaya. All right? So this equation essentially implies that P naught into small fn is equal to omega naught, or small fn is equal to omega naught over P naught. So for profit maximum, the first order condition I used only. For a maximum, you require a second order condition also, because it can be minimum or maximum. For a maximum, second order condition is negative. Second derivative should be negative. For a minimum, the second derivative should be positive, using the optimization rules. Very simple, but I don't want to get into that. Now, what you see here, for a profit maximum firm, how much would you hire labor? That is demand labor till marginal product of labor Fn, which is called marginal product of labor. Marginal product kya? dy dn. As output increases as you hire more people. That is the labor productivity. So what it is saying is essentially that marginal product of labor is equal to omega over P naught. What will it be? If omega is the money wage rate, omega over P naught will be, omega is the money wage rate, which is the wage that you pay to the labor per month, per day, per hour, per year, whatever. So omega over P will, what will it be? Real wage rate, because omega is the money wage that you pay, the rupee, then omega over P is the real wage. So what is saying? Marginal product of labor should be equal to the real wage rate. That's what it is saying. It should be equal to real wage. Marginal product of labor is equal to real wage. All right? So the company keeps on hiring people. For profit maximum, it works. I was telling you about this a few minutes ago when I explained the production function, the interest rate thing in the previous class. That companies keep on hiring people, also the same thing, till the wage it pays in real terms matches the real benefit, the gain it gets from the extra output by hiring you. I'm measuring your hiring by looking at how much I get from you in terms of output in relation to how much I have to pay you to come and work for me. Very simple. That's the equilibrium relationship. So essentially, therefore, marginal product of labor becomes the demand curve for labor. Because if marginal product falls, then demand for labor increases. I can keep on hiring people. I'll tell you something very simple. If now marginal product of labor is like this in the aggregate function I've written, Fn is greater than 0 and Fnn falling, it will be a downward sloping line. Fnn is falling, the slope is downward sloping. So what it is saying, if the cost to the company falls, it can hire more because the marginal product is declining if you hire more. So, you reach equilibrium later. You hire more, you reach equilibrium later, and you are willing to reach equilibrium later because the costs are low, you can keep on hiring. So, in terms of a diagram, therefore, what is happening is, if I draw it here, in terms of a diagram, what is happening is that if for a company, the marginal product of labor is downward sloping, and you have labor here, and the company is paying some omega over p as a wage. If omega over p is here, some value, then I hire people till that point n naught. If omega over p drops for some reason to a lower value, I can hire more people and go to n1. I can hire more people and go to n1. If omega over p drops, I can go to more people because my cost in hiring has gone down, and given diminishing marginal product, that means as mode is higher, productivity falls. The extra output that I get falls. This is an assumption I made. Therefore, for a lower cost, I can keep on hiring till my productivity in the company has fallen enough to reach the equilibrium point, which is equal to the real wage. So, essentially you develop a demand for labor function. How you hire more labor, how you hire less labor, demand for labor. Demand curve is always downward sloping. Supply curves are upward sloping. So, downward sloping basically means, for instance, a consumer's demand. If price is low, then I buy more goods. In this case, the price is the cost to the company of hiring people. If the cost is low in hiring people, I hire more people. So, it becomes a demand curve for labor. From a profit function of a company it comes, which is microeconomic theory. That's what we teach in microeconomics, the theory of firm. That for maximum profit, you hire people till marginal product is equal to real wage. And that simple algebraic relationship says the following thing, that there exists a demand for labor which is downward sloping. So, if the cost of hiring is low, I demand more people, I hire more people in my company. If the cost is high, then I hire lesser amount of people in my company. So, the macro demand for labor that I will draw, that I will show you in the next class, which is Wednesday, will essentially come from the profit function relationship of a company, which is micro theory. Unfortunately, I had to show you some micro theory here. Without the micro theory, which is very simple, profit function I write, which is total revenue minus total cost, and you do the first derivative, you get the relationship. Then you get the macro labor demand function also. But the supply function, labor supply function, is a much more complicated micro theory. I will not go into that. Unfortunately, I would bombard you with that equation on the board by saying you memorize it, because the micro theory there is much more complicated. But the micro theory behind the labor demand function, which I just started working for you on the board, is very simple, which you have the algebra. So, tomorrow or on Wednesday, I will conclude the labor demand function for the macro, and then I would just write the labor supply function on board without really explaining them much to you. A little bit of explanation in terms of intuition I will give you, but not the micro theory. But unfortunately or fortunately, for some of you it is good probably that you know this kind of a profit function exists in micro theory, which is used to get the labor demand function. Are you all right with it?